Okay, this is Dr. Williamson, and I'm going to solve problem 1634 for you guys. And it says we have this reaction 4A plus 3B goes to 2C. And the following data were obtained at constant pressure. And so we have different experiments, different initial rates of reaction, different initial concentrations of A and B. What is the order with respect to each reactant? Write the rate law, calculate K using the data from experiment 1. If you used experiment 2, 3, and 4, you should get the same value of K. Let's write the general form of the rate law, and it should be R equals K A to the M B to the N. Should be that. Okay. So now if we take a look at experiments 1 and 2, if we look at experiment 1 and 2, B was held constant, and we tripled concentration of A, and the rate, let's go here, 45 divided by 5 is 9. So 3 to the M, because we tripled the concentration, 3 to the M equals 9, right? Because 0.1 to 0.3 is tripling it. That's where I got this 3, because we tripled the concentration. 45 divided by 5 is 9. That's where I got this. And the only way this happens is if M is 2. So here we know M is 2. I'll put a little 2 up above there to remind myself. All right. So now from common sense, we could do it with logarithms, but here from common sense, we know M is 2. Okay. So we did that. Now we want to get N. So let's compare experiments 1 and 3. Why do we do 1 and 3? Because A was held constant. And experiments 1 and 3, we doubled B. That's why we put a 2 there. And the rate doubled. The only way that happens is if N is 1. So we put a 1 there. So what's the order with respect to each reactant? The order with respect to A is second order. The order with respect to chemical B is first order. And how do we write the rate law? Erase this. We would write the rate law as, let me change the color here. We would write the rate law as second order, first order, right? Okay. Except we wouldn't really write the 1, but I'm doing that as a teaching tool for right now. We would really write it like this. Now it says calculate K using the data from experiment 1. Remember, moles per liter is really molarity So I'm going to make it easier on ourselves. This is molarity. This is molarity. This is molarity. So R is going to be 5 molarity per minute equals K. And it's going to be 0.1 molarity. You have to make sure everything is squared. And 0.1 molarity inside. Okay. So if I do that, I'm going to have K is going to be 5 molarity per minute over 0.1 molarity entire thing cubed. Now, when I do that math, 5 divided by end up with 5,000. I'll erase this. Okay. End up with K equals 5,000. And it's to 3 sig figs. So since it's 3 sig figs, I better write this in 3 sig figs. Okay, so that's going to be 5.00 times 10 to the third. That's 3 sig figs. And I'm going to have molarity divided by molarity cubed. That's going to be molarity to the -2 and minutes to the -1. And that's how you do number 34 without using logarithms. Okay, guys, I hope that helps.